Good morning, everybody. Today we will talk about determinants. Determinant in algebra. Okay, what is a determinant? Before talking about the determinant, we will revise something about the matrix. You know that the matrix A equal 2 and 3 and 7 and 4. This is called a square matrix. Why square matrix? Because its rows, the number of rows, equal the number of columns. This is 2 times 2. Then this matrix of order 2 times 2. Then this is a square matrix. If you convert it or convert the writing for the matrix and change the two parentheses by using two vertical lines like this, it will be called the determinant of the matrix A. Then this is the determinant of matrix A. And you will write 2 and 3 and 7 and 4 between these two vertical lines. We have some difference between them. The matrix has no value, but the determinant, you can get its value by expanding it. How to expand it? You have a rule to get the value for this determinant. You will multiply the elements of the principal diagonal. But what is the principal diagonal of the determinant? The principal diagonal is the main diagonal, which is star from left from this determinant. This is called principal diagonal or the main diagonal. You will multiply these elements 2 times 4. Then subtract the product of the other diagonal or the non-principal diagonal, which is 3 and 7. This is called non-principal diagonal. You will multiply 3 by 7. And you can evaluate 2 times 4, it will be 8, minus 3 times 7, it will be 21. And subtract now 8 minus 21, it will be negative what? Yes, you can answer. Negative what? 21. 8 minus 21, it will be negative 13. Then the value of this determinant is negative value. By other way, you can get the value of the determinant may be positive, may be negative, may be 0. But the condition to get the determinant of the matrix, it must be a square matrix. It will be the second order or the third order. This is the way to expand the second order of the determinant. Okay, go on. Then if you have the determinant A is equal A, B, C, D in general, any elements, then A is equal, find the product of the principal diagonal, the elements of the principal diagonal will be AD, then subtract the product of the non-principal diagonal, BC. This is our rule for getting the value of the determinant or the square determinant. The second one, the third determinant. What is the third determinant? It is the determinant of a square matrix. It is a determinant of a third order matrix. Like what? Like A equals A, B, C, D, E, F, G, H, I. This is of order 3 by 3. If you change the two parentheses to two vertical lines and rewrite this matrix, you will get the determinant like what? Like this one. Determinant A, it will be vertical line A, B, C, D, E, F, G, GHI. How to expand this determinant? Please take care from how to get this one. Each element here, if you take the element A, has a place in the row and in the column. Then lies in the first row and lies in the first column. Then the order of this place, it will be Aij, this element, which is A11. Then I represent the place on the rows, and J represent the place in the column. If you add these numbers, 1 plus 1, and raise them to -1, it will be -1 all to the power 2, which is +1. Then the sign of this element, it will be positive. By the same way, you will take the order of each element be A1, 2. Then take -1 all to the power 1 plus 2. It will be -1 all to the power 3. 3 is odd, it will be -1. Then the sign here is negative. If you going to find the sign for the third one, it will be A13. A13. Then it will be -1 raised to power 1 plus 3, which is -1 to the power 4, which is +1. Then here positive. Consequently, you will do this thing, you will get positive, negative, positive, negative, positive, negative, positive, negative, positive. These are the signs of what? Of the minor determinant for each element in this determinant. If you remove the row of the first element, like this one, and remove the other column for the same element, you will get a minor determinant. You will get a minor determinant. Then you must take care, what is the minor determinant? Minor determinant, which is corresponding to the element when you remove its row and its column. Okay? Then how to expand now? If you have A is equal to anything, 2, 3, 1, 0, 4, -2, 3, 1, 4. Okay? This is a 3 by 3 determinant. How to get its expansion here? By applying the minor. You can use any row or any columns to get the expansion of this determinant. If you use the first row here, the elements of the first row here, you will write 2 multiplied by, this is positive, and this is negative, and this is positive. Then 2 is positive here, okay? This is positive. And you can write 2 only. Multiplying by what? The minor determinant, which is corresponding to by what? By removing its row and its columns. And write the left elements, which is 4, -2, 1, 4. By the same way, this is -3. And write the minor determinant, which is corresponding to 3. Then remove its row and its column. Then you will write the left elements, which is 0, -2, and 3, and 4. By the same way, plus 1 times the minor determinant, which is corresponding to it. Remove the row for 1 and its column, and take the left one. 0, 4, 3, 1. be 2, multiply, find the product of the principal diagonal. 4 times 4, it will be 16. Then subtract. 1 times negative 2, it will be negative 2. Minus 3, open 2 brackets. Multiply the principal diagonal. 0 times 4, it will be 0. Minus negative 2 times negative 3, it will be negative 6. Plus 1 times the principal diagonal. 0 times 1, it will be 0. Minus 3 times 4, it will be 12. Then evaluate each one. 2 times 16 minus negative 2, it will be plus 2. Then it will be 18. 0 minus negative, negative minus negative 6, negative by negative will be positive, then it will be negative 3 times 6. Plus 1 times 0 minus negative 12, it will be negative 12. 2 times 18, it will be 36. Minus 3 times 6 will be 18. And 1 times negative 2, it will be negative 12. Evaluate this value, 36 minus 18, it will be 18. 18 minus 12, 18 minus 12, 36 minus 18, it will be 18. 18 minus 12, it will be 6. Then the value of this determinant is 6. This is the first way to get the value of this determinant using the minor determinants for each element in any row or any columns, but by respecting the sign of each element in the rule, which we said before. We have another rule to get the value of this determinant. If you have A equal, determine 3, anything 2, 1, 5, 6, 0, 3, 2, negative 1. If you take the first column and the second column and copy them and paste beside the determinant, but take care from the distance between each two columns. The 3 to 1, write it here, 3, 2, 1. Take care the distance are equal. 5, 6, 0 will be 5, 6, 0. And you can apply the product of the principal diagonals, which is what? You can take, this is the principal diagonal, okay? Here, you have 3 principal diagonals. Then multiply the elements of each diagonal. 3 times 6 times negative 1. Plus 5 times 2 times 1. Plus 3 times 2 times 0. Okay, then subtract the non-principal diagonal. What is the non-principal diagonal? It will be the opposite direction here. Okay? Then these are the non-principal diagonal. You can start from right or from left as you like. You can say 5 times 2 times negative 1 plus 3 times 2 times 0 plus 3 times 6 times 1. I think you can do this product and get its value. This is the second way for getting the value for the determinant by copying the first column and the second column beside it. Okay? How to use the determinant for solving two equations. Kramer, this is a scientific mathematical person, used the determinant to solve the system of two equations or three equations, linear equations, like what? If you have 3x minus y equal to 7 and 2x plus y is equal to 8. And he said solve using determinant. Using determinant. Or using Cramer rule. First, in these equations, or in these two equations, the given equations, you have coefficient for the variable x and coefficient for the variable y, and you have some constants in the other side. You will write the coefficient of x and y, the two variables, 3, -1, 2, and 1 between two vertical lines, and we will name it by delta. Then this delta must be not equal to 0. To solve by using this rule, the determinant of the coefficient must be not equal to 0 to get the solution. Then evaluate this one, multiply the product of the principal diagonal. 3 times 1, it will be 3, minus -1 times 2, it will be -2. It will be 3 plus 2, which is 5. And here 5 is not equal to 0. Then you can complete. After finding the determinant for the coefficient of x and y, replace the coefficient of x in the first column by the constant 7 and 8. You will get delta x or delta sub x, okay? And write here 7, 8, and copy this column as it, -1 and 1. Evaluate 7 times 1, it will be 7, minus -1 times 8, it will be -8. Then it will be 7 plus 8, it will be 15. By the same way, find delta sub y, which is equal, take the constant by replacing it with the values of y. Then write 7 and 8 in the same place of y variable coefficients. Then we write 3 and 2. Get the value here. 3 times 8 will be 24, minus 14, it will be 10. Now you have delta and delta sub x and delta sub y. Now you can find x with this rule. It will be delta sub x over delta and y equal delta sub y over delta, which is equal, delta sub x is what here? It is 15. 15 over 5, which is 3. And y, it will be 10 divided 5, which is what? Which is 2. Then the solution set here, it is the set of order pair 3 and 2. But if you're going to check your answer, it is correct or not, you will take this value. This is the value for x, and this is the value for y. And go back to what? Go back to the equations. We say, or we said before, x is equal to what? 3. And y is equal to what? 2. Then here, if you take x equal to 3, and here is 2, 3 times 3 it will be 9. 9 minus 2, it will be 7. Then the first equation is correct equation. By checking that, second one, 2 times 3, it will be 6. Plus 2, it will be 8. It will be correct. Then our solution is correct answer. Then the solution set for this one is the set of ordered pair 3 and 2. Thank you, my dear students, and good luck. Thank you.